a number of you that are missing on a particular day or not. All these lessons are being recorded. I'm recording it right now. They're on our website. Now, you're expected to go back and watch it, or come to tutoring after school, or do something, or pay attention when I'm going over homework, which most of the concepts are retaught then. Okay? If you miss, you have to do something to make it up. Most everything that we've done up till now has not really been covered by an Algebra 2 SOL. This one is. In fact, it's fairly heavily covered by the Algebra 2 SOL, absolute value, equations and inequalities. So this is really the first one. I mean, we did do a little bit of properties at the beginning. That's like barely covered at all on the SOL, 1 out of 50. This one, it might be like 3 out of 50. It makes it a lot more important. And I know you're all familiar with absolute value. We've actually talked about it a little bit. We talked about it when we were talking about the distance between points on a number line. We actually kind of threw that in already. But today we do equations and inequalities. And we know what absolute value means, right? Absolute value is the positive distance from 0 on the number line, which means that it doesn't matter if you're to the left of 0, to the right of 0, you're still going to say a positive number, right? So the distance from -3 to 0 is +3. The distance from 0 to +3 is +3, right? The net effect of that is, the result of an absolute value is always positive, right? It doesn't flip the sign automatically, right? It only flips if it's negative. Keep the clock going there in case you're watching the video and not sure whether anything's going on. You'll see the clock ticking. Tick, 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 tick. Good? Good. All right, so in an absolute value equation, right, we have an absolute value symbol on one side of the equal sign. It might be alone, it might not be. I'm just giving you the most simple example of it, right? An absolute value of x equals 5. So what if we plug in x equals 5? Would that be true? If I plug in a 5 here, would it be true? Sure it would be, right? Because what's the effect of the absolute value? Nothing, right? It's already a +5, so the answer would be true, right? What if I plug in x equals -5? Would it be true? What's the effect of the absolute value? Flips the sign. So it's +5, and +5 equals +5. Yes, it's true. Now, we're not going to have many absolute values that are as simple as an x, right? What we're going to get in the absolute value is going to be some kind of expression, right? Something that's got more than one term, possibly, some constants, coefficients, things like that. So if you have an expression equal to some constant, some number, then you're going to set that expression equal to the number, and you're going to set it equal to the opposite of that number, just like this. Right? You're going to set the x equal to 5 and set the x equal to -5. You do the same thing. Whatever's inside the absolute value, set it equal to the positive right-hand side, set it equal to the negative right-hand side. And at that point, you don't have any absolute values anymore. Those are just two separate equations that you're going to solve. So how many answers are you going to get? 2. Right? You expect to get 2 answers from an absolute value equation. Good. Let me know if it's going too fast. Devine, you okay? Okay. So here's an example. The absolute value of 2x minus 1 equals 5. Okay, that 2x minus 1, that's the expression. Right? That's what I mean by an expression. It's not just an x, but it's an expression that involves x. So again, what would the strategy be? We need to break it up into two different equations. What will the two equations be? Remember, we're going to set the expression equal to the right-hand side. Because if this 2x minus 1 equals 5, what's the effect of the absolute value? Nothing, right? It'll be 5 equals 5, solves it. But if that 2x minus 1 equals negative 5, when you take the absolute value, then it equals 5. So what we need to do is solve for the x values that make that expression equal 5 and negative 5. And those will be our answers. Yeah, Jay. Here? Here? There's no absolute value when you write those equations. So what we do from this step to this step is write two equations, no absolute values. Okay? You want to break it down. Don't have any absolute values when you get to this place right here. And you can't try to, for example, do algebra when you've got the absolute value symbols. You can't go here and say, I'm going to add 1 to both sides. Until you've broken down the absolute value in a way that there are no absolute value symbols, you can't do the algebra. Now that you've written them without the absolute value, you can do the algebra. Okay, so add 1 to both sides. 2x equals 6, x equals 3. Add 1 to both sides. 2x equals negative 4. Right, divide 2, x equals negative 2. Two answers. What was I going to say? You know, just, again, you know, a few when I'm going around, you know, you're showing me stuff, your homework, which is like, there's no work or anything. Most of you would probably self-identify that you're not very good at math. And people have been telling you for years, you need to show your work. You need to show your work. You don't do it like as punishment. That's how you get things right. If I was solving this for myself, I would have done all that work for me, not to show you, just for me. That's how you get it right. You trying to say, I'm going to do it and not show my work is just like a recipe to not be very good at this stuff. Right? So you show your work. I think I was telling somebody, if I see an answer on a test that there's work to show, the answer is 1. The work is 4. Okay? So just giving me an answer isn't going to be work very much. You'll fail. Just giving me all the right answers and no work, you failed by a lot. Show work. Okay. So now this is the more typical kind of absolute value equation, right? The one we did on the last slide was pretty simple. And these are the steps, right, written over here. The steps are, first, you've got to isolate the absolute value, right? The ones we already looked at, the absolute value was alone on the one side of the equal sign. In this one, it's not. So just like when we solve for a variable in an equation, we got to figure out what operations can I do to both sides to strip away everything that's with that absolute value so it's the only thing on that side of the equal sign. And what are the two things that are with the absolute value that you need to get rid of? The 2 and the 3. So the question will be, which one are you going to do first? I mean, just think of it like this. What if this had said 2x plus 3 equals 7? Just a straightforward algebra equation. What would you have done first? You subtract the 3, and that's what you want to do here. Right? Don't try to divide by the 2 first. Take away the 3 first. So now we have 2 times the absolute value of x plus 9 equals 4. It's like in this one, it would be like saying 2x equals 4. And then what would you have done? You want to isolate the absolute value? Divide by 2, just like you would have done there, right? Divide by 2, divide by 2. You know, but whatever, don't try to do distributive properties. 2x, 18. You can't do algebra when you've got the absolute value symbols, right? So this is divide 2, divide 2. Absolute value of x plus 9 equals 2. Okay, that's the first step. Isolate the absolute value, which means just like solve it like it's an equation. Okay, the second step I'm calling undo. Sometimes I call it breakdown, but undo. Meaning, in this case, because it's an equation, break it into 2 equations, right? Like we've already shown. How will we break this one into 2 equations? What are the 2 values that this expression could have and solve this equation? It could be 2, or it could be negative 2. Either one, when you put the absolute value around it, you get positive 2. So set this equal twice, x plus 9 equals 2, and x plus 9 equals negative 2. Solve. Subtract 9, subtract 9. X equals negative 7. Subtract 9, subtract 9. X equals negative 11. Okay, and then of course you could check them. You could plug them back in. Negative 7 plus 9 is 2. The absolute value of 2 is 2. 2 times 2 is 4, plus 3 is 7. Negative 11 plus 9 is negative 2. Absolute value makes it 2. Same thing. So these are the steps. And the steps, because we do 3 different things today. We do equations, we do greater thans, we do less thans. And they all have their own steps. They're very similar, but not the same. These are the steps for equals equations. So try that one. See if you could do the same thing. You should get 2 answers. Who's got an answer? Anybody? Perfect. What the heck are you doing? A plus 1. Remember, at that step, you're dividing by 3, not subtracting 3. Divide by 3. Okay? Yes. Good job. And yes, good job. How are you doing? Good job. What are the answers here? When you negative 3 minus 2 is negative 5. Get it? JV? Right. Jose? Right. Okay, everybody's doing great on that. So what were the 2 steps to isolate the absolute value? Add 1, divide by 3. Right? 3x plus 2 equals 9. What do we do at this step to get rid of the 3? Divide. Okay. Believe me, I see this in a lot of classes, not just your class. I'm saying like pre-calculus classes, that students at this point will subtract 3. Right? That's a multiply. So the way to get rid of it is to divide. Okay. So divide 3, We have x plus 2 equals 3. Okay, now we undo the absolute value because we can't do any algebra with absolute value symbols, and that gives us two equations. X plus 2 equals 3, or x plus 2 equals negative 3. And when you solve, you get 1 and negative 5. Okay. Now this problem is different. What makes this one look different? We have x's that are inside the absolute value, but we have x's that are outside the absolute value. Okay, you still use the exact same procedures, exact same. Whether or not there's x's inside, just inside, or both, use the same procedures. First step would have been to isolate, but it's already isolated. The absolute value is. Second step, write two equations. Okay. Now, when we wrote the two equations, when it was a number, right, we wrote on the right-hand side of the equations the positive number and the negative number. That's pretty much what you do here too, right? We're going to write this as 5x minus 2 equals 7x plus 14. I mean, exactly the same thing, you know, the right-hand side as it is. And then we'll do it one more time like this. 5x minus 2 equals negative 7x plus 14. Right. You write it twice. Once as it is, once with a negative in front of it. Which we can simplify now. That's 5x minus 2 equals negative 7x minus 14. Which leaves us, again, with two equations to solve. They're a little more complicated, but not a lot. They get more complicated when we get later in the class, and we can actually have like quadratic expressions inside the absolute value. At this point, we haven't covered that yet. So all we can really do is get the kind of linear equations, which, you know, we've done so far. That's it. So solving this to be minus 5x minus 5x. We're going to get negative 2 equals 2x plus 14 minus 14 minus 14. Okay, negative 16 equals 2x. X equals negative 8. Right? Okay. Which one of the variable terms should I cancel and move? 5x or negative 7x? The negative 7, right? Negative 7 is smaller than positive 5. So add 7x to both sides. We get 12x minus 2 equals negative 14. Add 2. 12x equals negative 12. X equals negative 1. Two answers. So that isolate didn't have to do. Break down, undo, we did it. Solve, we did it. What's the fourth step? Check, okay? When you have variables inside and outside, it's very important to check because most of the time, one of those answers won't check. Okay, let's see how we can check that out. Okay, looking at this here, we have the absolute value equals 7x plus 14. That's the original equation. What am I going to get if I put negative 8 in the place of x here? 7 times negative 8 plus 14. What's 7 times negative 8? Negative 56 plus 14 would make negative 42. So without even figuring out what's inside the absolute value, is it possible that this absolute value equals a negative number? Absolute values are always positive. There's no way that we could have this absolute value equal negative 42, which means this answer here is not an answer. You did everything right, but it's not an answer. And when you get that, it's called an extraneous solution. Right? This is extraneous. It means it's not an answer. It's not a solution. Yeah, you got to indicate in some way that this is not an answer because it didn't check. You could just say extra. You could say EXT, right? Big E. Now, will we have the same problem with the negative 1? 7 times negative 1 plus 14, that's negative 7 plus 14, that's positive 7. So that one we won't have the same trouble with, right? But this one, because it made that side to a negative number, can't be the answer. Absolute values are always positive. So the only answer is this. Now, if you had this problem to do on a test, and you got all the way down to here, and you had both of those right answers, and you just didn't check, you still did pretty good. I mean, every problem I look at is 5 points. That's the way I look at it. You'd probably lose a couple for not checking, but you're going to get the majority of the credit just because you were able to break it up, solve twice. It's not easy. We don't generally do great on these problems. Now, when it comes to absolute value less than or equal to, we need to kind of look at the number line and try to imagine what parts of the number line, when I say that the absolute value of x is less than 5, then if I plug in numbers that come from here between 0 and 5, would that make it true? If x is 1, would it be true? Is 1 less than 5? Sure, that would be good, right? What if I put in numbers between negative 5 and 0? For example, if I plug in negative 1, but I take the absolute value, then it's positive 1, and that's less than 5. So actually, any number in here, when you take the absolute value, is here, and it's less than 5. So for an absolute value to be, an absolute value less than to be true, we need our expression to be anywhere in between those two numbers. Could I put in negative 6 for x? Negative 6 absolute value is 6. Is 6 less than 5? No. So it would not include numbers to the left of negative 5. And obviously it's not going to include numbers to the right of 5. So for an absolute value less than, we're looking at a middle piece of the number line like that. And generally, I'm going to say an absolute value of an expression is less than a number, then that means that the expression is in between the negative number on the left and the positive number on the right. That's a 3-part inequality. Like this one here, I would have said negative 5 is less than x is less than 5. Which means between. X is in between negative 5 on the left, positive 5 on the right. Now, that's actually, as we learned last time, that's kind of like a compound statement with an and tying them together. It's both x is greater than negative 5 and x is less than 5. But we prefer to write it as a 3-part inequality and just think of it as between these two numbers. So our steps are very similar. First we isolate, then we undo. This time the undoing is going to involve a 3-part inequality. And then we're going to solve for x in the middle part of the 3-part inequality. So is this one, anything to do to isolate this one? No. So we move on to the next. What's the 3-part inequality? All right, it's going to have the expression 2x minus 1 in the middle. What goes on either side? Five and negative 5. All right, so the positive and the negative right-hand side. Okay, that's our three-part inequality, no absolute value symbols anymore. Okay, now when you solve a three-part inequality, we're trying to isolate x in the middle. So it's thinking the same thing. What do I need to get rid of so that this x is alone in the middle of that? We have to add 1, divide by 2. Okay, the only thing is, since there's 3 parts, you got to do everything to all 3 parts. Like add 1 means add 1 here, add 1 here. Negative 4 is less than 2x is less than 6. What else? To isolate the x, we have to divide 2. Divide 2, divide 2, divide 2. So negative 2 is less than x is less than 3. That's the solution. It says to graph it. So to graph that, we draw a number line. We need a negative 2, and we need a 3. Should we have open or closed circles? Open circles. And then the shading should be between, right? The x's between those. Jaden, you can. So try this one. All right, it's already isolated. So really, you got to, how do you rewrite that without the absolute value symbol? Hint, three-part inequality. That's not a three-part. You got to have a negative 8 here. Negative 8 is less than 3x minus 4. We just add over here. Negative 8 is less than. Right. Now when you added 4 there, add 4 there. Get it? Okay. Good job. Now, you have the symbol. Because it's the less than. And then graph it. So you write a three-part inequality. That should have been everybody's first step, right? Everybody's first step, write that. Okay, solve for x in the middle. What steps did you have to do to solve for x? Well, plus 4 in all 3 parts, right? Plus 4, plus 4, plus 4. Negative 4 is less than 3x is less than 12. Divide by 3. So negative 4/3 is less than x is less than 4. And if you graphed it, right, negative 4/3 is less, so I'll put that here. 4 is here. Open circle, shade in between. How many of you remember doing something like this somewhere in the past? And how many of you, your teacher did not show you the three-part inequality, but had you do two different equations? I'll just say probably because they don't really understand it very well, which is something that happens these days when they push these levels of math down to lower and lower grades. You get teachers that actually, they were teaching the lower grades because they didn't want to teach math, and now they're teaching, throwing the algebra down to sixth grade, and they don't want it, you know. But the proper way to do these is with a three-part inequality. You know, in a class like this, if you end up doing the two-part, you know, you could have written this different. You could have written it like this: x is greater than negative 4/3. X is less than 4. But if you don't combine them with the word and, it's not right. You got to think of it as a compound inequality. When you have a three-part inequality, that's implied. It's there. No and, doesn't matter. It's there. It's telling you it's in between, which implies both greater than that and less than that. Okay. Now, for an absolute value greater than, it's different. And if you think of it, if the absolute value of x is greater than or equal to 5, then clearly 5 is part of the solution, right? 5 is greater than or equal to 5. Is negative 5 part of the solution? What's the absolute value of negative 5? 5. So that's part of the solution. Okay. Is 6 part of the solution? Is 6 greater than or equal to 5? Sure. So the shading is going to go that way. Is negative 6 part of the solution? Which question? If it says or equal to, it's closed. If it doesn't say or equal to, it's open. Okay? Is negative 6 going to be part of the solution? Yeah, because if you take the absolute value of negative 6, you get positive 6, and that's greater than 5. So the shading goes there. Right, so either, in this case, we would say x is less than or equal to negative 5. X is greater than or equal to 5. It's two inequalities, and they are a compound inequality tied together with or. It could be either one. It could be to the left of negative 5. It could be to the right of 5. Compound or. And you do have to write it two inequalities, and you got to use the word or. So we will have expressions that are not as simple as just x, but it's still the same principle, right? If you have an expression, an absolute value is greater than or equal to a constant, then you're going to write two inequalities. The expression, no absolute values, is greater than or equal to that constant, or it's less than or equal to the negative. Like, right? Here's our new steps. Isolate, undo, and undoing in this case is going to be two inequalities, a compound or. Solve, make sure to keep the word or between your solutions, and then graph. What do I need to do to isolate the absolute value? Add 5. Absolute value of 5x plus 10 is greater than or equal to 5. Oh, you're right, 15. Okay, we isolated. What are my two inequalities I'm going to write? Is 5x plus 10 is less than or equal to negative 15. Okay. Solve. What's that? Yeah, negative 15, right? On this side, it's less than or equal to the opposite. Okay, subtract 10. 5x is greater than or equal to 5. Divide by 5. X is greater than or equal to 1. Subtract 10. 5x is less than or equal to negative 25. x is less than or equal to negative 5. Okay, now, that is our answer once we put an or in between them. Right? That is the answer. And the graph will look like, right, negative 5 is on the left, 1 is on the right, open or closed circle. Closed and closed, right? If x is greater than or equal to 1, where is the shading? Is it to the left or to the right? To the right. Greater than on the number line means to the right. Right? If x is less than or equal to negative 5, where's the shading? To the left. Less means to the left. So that's the graph. And the absolute value greater than, the graph always looks like that. The ends are covered, the middle is open. The absolute value less than, it's the opposite. The middle is covered, the ends are open. Okay. So think about this now. State whether these three here would always be true, never true, or sometimes true. If you have the absolute value of an expression equals a negative number, that's never true, right? It's never true, and you'll get that in some equations. I think there's one in the homework where its absolute value equals negative. You don't need to like set it equal to the positive and negative right-hand side. You don't have to. It can't be true. Would not check. If you check your answers, it will not work. So this is never true. If you have the absolute value of an expression is less than a negative number, is that possible? No. Absolute, the absolute value will be positive. That's like saying a positive number is less than a negative number. No. Never. And what if you get an absolute value of is greater than a negative number? Is that always true, sometimes true, never true? It's always true, right? If you get an absolute value and there's a greater than, and on the right-hand side it's a negative number, you just say always true. You don't need to solve it. Always true. Okay. Okay. Good. Janine? Okay. Green. That was it. Absolute value equations and inequalities. That's the homework. I'm going to write that down, and then we're going to take a quiz.